Hi to everyone. In this video, we are going to discuss the theorems on limits.
The objectives of these lessons are illustrate the limit laws,
And apply the limit laws in evaluating the limit of algebraic functions, polynomial, rational, and radical functions. So these are the theorems on limit. Limit of a constant where x approaches to a is equal to the constant. That is the limit of constant. Next, limit of identity function. The limit of x where x approaches to a is equal to a. Limit of product of constant and a function. Limit of c of f of x where x approaches to a is equal to c. Limit of the function f of x where x approaches to a. So if limit of f of x is equal to L and x approaches to a, and the limit of g of x where x approaches to a equal to m, then the limit of f of x plus or minus g of x where x approaches to a is equal to the limit of f of x where x approaches to a plus or minus the limit of g of x where x approaches to a, and that is equal to L plus m. That is limit of sum or difference of function. Limit of f of x times g of x where x approaches to a is equal to the limit of f of x where x approaches to a times the limit of g of x where x approaches to a. So since the limit of f of x where x approaches to a is equal to L, and the limit of g of x where x approaches to a is equal to m, therefore this is equal to the product of L, m. That is the limit of product of function. The limit of f of x over g of x where x approaches to a is equal to the limit of f of x where x approaches to a divided by the limit of g of x where x approaches to a. And this is equal to L over m. But take note, m should not equal to 0. And this is limit of quotient of two functions. Limit of f of x raised to n where x approaches to a is equal to the limit of f of x where x approaches to a quantity raised to n. That is equal to L raised to n. And this is called limit of power function. Limit of nth root of f of x where x approaches to a is equal to the nth root of the limit of f of x where x approaches to a, or that is equal to nth root of L, and that is the limit of radical function. To understand these theorems of limits, let's have some examples. Number 1, limit of 6 where x approaches negative 4. This is equal to 6. This is a limit of a constant. The limit of a constant where x approaches to a is equal to the constant. Number 2, limit of negative 3 where x approaches to 4. This is also a constant. Limit of a constant is equal to the constant. So this is equivalent to negative 3. Number 3, limit of 3 over 5 where x approaches to 0. 3 over 5 is a constant. So this is limit of a constant. So the answer here is 3 over 5. Limit of x where x approaches to 3. Number 4, limit of x where x approaches to 3. This is limit of identity function. So limit of x where x approaches to 3. This is equivalent to 3. Number 5, limit of x where x approaches to negative 4. So this is an identity also. So x is approaching to negative 4. So therefore, this is equivalent to negative 4. Number 6 example. This is a limit of product of constant and a function. So 6 is a coefficient. So we can write 6 before the limit. So this will become 6 limit of x where x approaches to 4. So then, this is now an identity, limit of x where x approaches to 4. That is, limit of x approaches to 4 is equivalent to 4. So take the product of this. 6 times 4 is 24. You're going to simplify. Next, number 7. The limit of 4x where x approaches to negative 5. So we can write 4 before the limit. 4 limit of x where x approaches to negative 5. Then, this is an identity. Okay, limit identity. So we have 4 times negative 5. So 4 times negative 5 is negative 20. Next, number 8. Limit of 3x squared minus 5x where x approaches to 2. So if we're going to solve this, we can write as limit of 3x squared where x approaches to 2 minus limit of 5x where x approaches to 2. That is the limit of sum or difference of function. And then apply the other theorem. So since this is a coefficient, so we can write 3 limit of x squared where x approaches to 2 minus limit 5 limit of x where x approaches to 2. So this is 5 coefficient. We can write in the before the limit. Then apply now the other theorem. So limit of x squared where x approaches to 2. We can write this as 3 quantity of limit of x where x approaches to 2 squared minus 5 limit of x where x approaches to 2. Then simplify. So limit of x where x approaches to 2, that is a identity function, limit of identity function. This is now equivalent to 2 squared minus 5 limit of x where x approaches to 2. This is 5 times 2. Then simplify. 3 times 2 squared minus 5 times 2. 2 squared is 4 times 3. This is 12. 5 times 2, that is 10. So the final answer is 2. 12 minus 10 is 2. Number 9. Number 9 example, the limit of 3x plus 1 half where x approaches to 2. Okay, so let's apply the limit of sum of function. So this will become limit of 3x where x approaches to 2 plus limit of 1 half where x approaches to 2. So since this is a coefficient, we can write this before the limit. So 3 limit of x where x approaches to 2 plus limit of 1 half where x approaches to 2. Limit of identity function, limit of x where x approaches to 2. This is equivalent to 2. So 3 times 2 plus limit of 1 half where x approaches to 2. This is an constant function. Limit of constant, 1 half is a constant. So that is equivalent to 1 half. Okay, so 3 times 2 is 6 plus 1 half. This is equivalent to 6 and 1/2 or 6.5. Number 10. Limit of 2x minus 1 where x approaches to negative 4. So this will become limit of 2x where x approaches to negative 4 minus limit of 1 where x approaches to negative 4. Next, this is a coefficient, so we can write 2 limit of x where x approaches to negative 4 minus limit of 1 where x approaches to negative 4. So this is now an limit of identity. A limit of identity. So limit of x where x approaches to negative 4. So this is now equivalent to negative 4. 2 times negative 4 minus limit of 1 where x approaches to negative 4. This is just only a constant. Limit of a constant is equal to the constant. So limit of 1, this is equivalent to 1. Then simplify. 2 times negative 4 is negative 8 minus 1 is equal to negative 9. Number 11. So the limit of 2x plus 1 times the quantity of 3x minus 2 where x approaches to 3. So let's simplify. So this will become limit of 3x plus 1, 2x, sorry. 2x plus 1 where x approaches to 3 times the limit of 3x minus 2 where x approaches to 3. So this is limit of product function. Then simplify. So this will become limit of 2x plus limit of 1 where x approaches to 3 times limit of 3x where x approaches to 3 minus limit of 2 where x approaches to 3. Then simplify. So this will become limit of 2x where x approaches to 3. That will become 2 times 3 plus limit of 1 where x approaches to 3. Limit of a constant, which is equivalent to 1. Limit of 3x where x approaches to 3, that will become 3 times 3 minus limit of 2 where x approaches to 3. This is a limit of a constant, so limit of 2 is equivalent to 2. Then simplify. 2 times 3 plus 1 is 7. Then 3 times 2, 9 minus 2 is 7. So this is equivalent to 49. Number 12. Limit of 5x times 2x. So this is equivalent to the limit of 5x times the limit of 2x where x approaches to 1. Okay, next, this is a constant. We can write as 5, a coefficient, 5 limit of x where x approaches to 1, so that is times 1, times the limit of 2x where x approaches to 1, so this is equivalent to 2 times 1. So 5 times 1 is 5, times 2 is equivalent to 10. So the limit of 5x times 2x where x approaches to 1 is equal to 10. Number 3. Limit of x over 2 where x approaches to 5. So this will become limit of x where x approaches to 5 over limit of 2 where x approaches to 5. So limit of x where x approaches to 5, that is equivalent to 5. Limit of 2 where x approaches to 5, this is limit of constant. The answer is 2. So 5 over 2 is the limit of x over 2 where x approaches to 5. Number 14. The limit of 2x plus 4 over 3x minus 2 where x approaches to negative 2. So this is equal to the limit of the numerator 2x plus 4 where x approaches to negative 2 over the limit of 3x minus 2 where x approaches to negative 2. So we're going to find the limit of the numerator and the limit of the denominator. The limit of numerator, that will become 2 times negative 2 plus 4 over, in the denominator, that will become 3 times negative 2 minus 2. Then simplify. Negative 2 times 2, that is negative 4, plus 4 over negative 6 minus 2. So this is equivalent to 0 over negative 8, or equivalent to 0. Number 15. The limit of x plus 3 quantity squared where x approaches to 1 over 2 or 1 half. So this is now equivalent to the limit of x plus 3 where x approaches to 1 half quantity squared. So this is limit of power function. So the limit of x plus 3 will become the limit of x where x approaches to 1 half plus the limit of 3 where x approaches to 1 half quantity squared. So the limit of x where x approaches to 1 half, this is now 1 half, plus the limit of a constant 3 is equal to 3 squared. So add 1 half plus 3 is 7 over 2 in mixed fraction. Then squared, this is equivalent to 49 over 4. So that's the limit of x plus 3 quantity squared where x approaches to 1 half. 16. The limit of 2x minus 3 quantity squared where x approaches to negative 2. So this is equivalent now to the limit of 2x minus 3 where x approaches to negative 2 squared. So find the limit of 2x minus 3. So limit of 2x where x approaches to negative 2 minus limit of 3 where x approaches to negative 2 this squared. Then this is now a limit of 2x where x approaches to negative 2 is equivalent to 2 times negative 2 minus limit of 3, that is a constant, equal to 3 squared. So simplify, 2 times negative 2 is negative 4. Negative 4 minus minus 3 is negative 7. Then negative 7 squared, that is 49. Example 17. The limit of d where d approaches to 4 over 9. So this will become limit square root of limit of d where d approaches to 4 over 9. So limit of d where d approaches to 49, that is square root now of 4 over 9. So square root of 4 over 9 is 2 over 3. Okay, that's number 17. Number 18. The limit of square root of 5b plus 3 where b approaches to 1 is equal to the square root of the limit of 5b plus 3 where b approaches to 1. Then the limit, apply now the limit of sum. Limit of 5b where b approaches to 1 plus limit of 3 where b approaches to 1. So limit of 5b where b approaches to 1, that will become 5 times 1 plus limit of 3, which is constant. Limit of a constant, that is equivalent now to 3. 5 times 1 is 5 plus 3, that is 8. So square root of 8. 8, that is 4 times 2. Okay, so simplify this radical, square root of 8, which will become square root of 4 times 2. Then square root of 4 is 2. Then this is 2. So final answer is 2 square root of 2.